Cleansing action of soaps and detergents. Have you ever tried mixing oil and water? Oil and water are immiscible liquids. If oil and water are mixed together, oil separates and forms a layer of its own. Oil floats on water as it is less dense than water. Why don't oil and water mix? Water molecules are bipolar molecules. They form strong electrostatic bonds with each other. Oil molecules, on the other hand, are non-polar and do not make bonds with the polar water molecules. The bonds that hold oil molecules together are weak van der Waals forces. Observe that oil molecules are large as compared to water molecules. For the mixing of any two liquids, their molecules must have similar natures. Since their molecules are not similar, water and oil do not mix. Molecules that carry charge are attracted to water and are called hydrophilic or water-loving, while molecules without charge lack affinity for water. They are known as hydrophobic. Oil is a hydrophobic liquid. If a mixture of oil and water is agitated vigorously for a sufficient period of time, an emulsion is obtained. The emulsion consists of minute droplets of oil dispersed in water. What happens if this emulsion is allowed to settle down? The oil droplets slowly coalesce and form a separate layer as before. We can infer that the oil and water emulsion is not a stable system. Let's add some soap or detergent to the mixture and see the magic. Addition of a little soap or detergent before agitating the mixture helps in the formation of a stable emulsion. The soap or detergent acts as a surfactant or emulsifier. The surfactant molecules surround the oil droplets and prevent them from coalescing. The cleansing action of soaps and detergents is due to their power to emulsify oil and dirt. Come, let's learn about the cleansing action of soaps and detergents in this module. At the end of this module, you will be able to describe the cleansing action of soaps and detergents. Soaps and detergents are surfactants which help to dislodge dirt and grease by emulsifying them and thus help clean articles. Let's take a look at the molecular structures of soaps and detergents. Observe that they have similar structures. Each molecule is composed of a long, non-polar hydrocarbon chain, which is hydrophobic in nature, and a short polar head, which is hydrophilic in nature. The hydrophilic end is attracted by water molecules, whereas the hydrophobic end of the molecule is repelled by water but is attracted by non-polar substances like oil. The cleaning action of detergents and soaps is attributed to this special feature. Have you ever wondered how soaps and detergents work to get rid of dirt and grime? Here's how. Dirt or grime generally has an oily component. Water cannot dissolve oil, and hence water by itself cannot take away dirt. This is where soap or detergent comes of use. Dirty clothes are soaked in water containing soap or detergent. When detergent or soap molecules come in contact with the oil or dirt on the fabric, the non-polar portion of such molecules attaches itself to that bit of grime or oil. Over time, more and more detergent molecules gather around it and a micelle is formed with the oil or dirt inside it. A micelle is a ball-shaped collection of detergent or soap molecules with the hydrocarbon ends clumped together on the inside and the polar heads on the outside. Eventually, through either agitation or stirring of water or rubbing, these micelles are lifted off from the fabric surface and get into the wash water. Remember that because of the charge on the heads of the detergent molecules, the outer surface of the micelle is charged. Since these micelles all have similar charges, they repel each other and remain suspended in the water. These get removed when the water is drained off. Repeated rinsing and wringing remove all such micelles and make laundry crispy clean.